furthering our knowledge of unit rates, we're going to take things that we have covered before, fractions, and we've even done some work with complex fractions. And we're going to be applying it to what we know about rates and unit rates. So first off, we want to start with a little warm up to make sure our skills are good for working with fractions, because we're going to work with complex fractions. We're going to end up doing a little bit of review here of multiplication. And so the concept that I wanted to make sure you review for multiplication of fractions, not only just how to do it, but reminders that these numbers that are across from each other, you can do your simplifying, your canceling first, and it's going to help you out a lot in the end if you're going to be ending up doing, so like I would be doing 35 times 21. But if I do my cross canceling, so 10 and 35 both have 5 in as common as in a factor. So if I divide by 5 and divide by 5, and then I look across from each other, the 12 and the 21, they both have 3 in common. So there's a 3 divided by 3 and divided by 3. So now when I multiply to multiply fractions, I multiply the numerator and I multiply the denominator. That's just going to make my work a lot easier. And now I want to think, do 8 and 49 have anything in common as far as a factor goes? No, so that's my final answer for this fraction. So that was the one thing I wanted to remind you of, and keep that in mind as you come across multiplication problems, is to cross cancel. Look for opportunities to cross cancel for simplifying. And the other thing to remind you of is division. When we are doing a division problem, we are going to change this into multiplication before we actually do the problem. So reminder, our phrase that we use, we keep the first term, we change to multiplication, and then we flip to the reciprocal. So division by fraction is the same as multiplication by the reciprocal. So reciprocal, that word tells me that reminds me of the flip. So I then have a multiplication problem that I can do my cross canceling. 3 and 9 can both be divided by 3, so that would be a 1, and that would be a 3. Now I multiply numerators. 1 times 3 is 3, and denominators, 1 times 5 is 5, so my answer is 3. So just a couple of reminders, tips, because these are the skills we're going to be using throughout this video. So as far as what a complex fraction is, complex fractions are fractions that have one or more fractions in, it could be in the numerator, the denominator, or both. So examples of what that would look like, there's a fraction in the numerator here. It's 1/2 divided by 4, or 1/2 over 4. Here there's a fraction in the numerator and denominator, 3/4 over 4/9. And here's one where there's a fraction in the denominator. Notice it's a mixed number. The fraction could be a proper fraction, an improper fraction, a mixed number, any of those, and numerator, denominator, or both, all are considered to be complex fractions. Our goal is to simplify these fractions, and they're not simplified until both the numerator and denominator are integers. Now, reminder, we did, if you look back at, if you remember the foldable we did, it had the layers on the inside. It had, you opened up, and then there was another flap, and then you opened that flap. That told you the different number sets. Integers was the number set that had the negative values, 0, and then all of the counting numbers. So it was the whole numbers and their opposites were what we used as a definition. But basically until there aren't any fractions anymore. And now, so what you might be tempted to do is to take something like this and say 1/2. Oh, okay, I'm going to make that not a fraction anymore. I'm going to make that a decimal. Fractions, again, like fractions or decimals there, they're not integers. If you have a fractional or decimal portion, that's not an integer, so that's still not simplified. So that doesn't really change our issue. It's okay to have a fraction as an answer, but it's not okay to have a fraction within a fraction as far as simplifying. So that's our goal today. So for simplifying complex fractions, it's not new material, it's just a different way of looking at it. So when we take a complex fraction, so I have 2/3 divided by 3/4, my first step is going to be to rewrite this as division. Now, some of you might be saying, well, isn't it already division? And yes, so when we see that fraction bar in the middle, we need to see this as division, because what this is really saying is 2/3 divided by 3/4. So a complex fraction looks, in my mind, I always think it looks more difficult than it is. So to do 2/3 divided by 3/4, I'm going to rewrite it as a division. As a division problem, rewrite the fraction as a division, and then change to multiplication, just like we normally do with our division problems with a fraction. And then step 3 is going to be to finish the problem. So I'm going to change, flip, and then I'm going to multiply. So my numerator, I look for cross canceling. 3 and 4 don't have any common factors. 2 and 3 don't have any common factors. So I'm going to multiply. The numerator is 8. The denominator is 9. So my answer is 8/9. So let's follow. So this is I do. So you should be following along and working through the problem and taking notes as you go along. So for this problem, let's do the steps we see above. We're going to rewrite it as division. So what's being divided? We have, and I'm looking for this fraction bar. It looks a little bit bolder, a little bit wider than the fraction. So here my fraction is in the denominator. So I have 14 divided by 7/9. So I'm going to rewrite the problem as division, and then I'm going to go ahead and change it to multiplication. So I'm going to have 14 times the reciprocal of 7/9, which is 9/7. Now, if I'm going to multiply here, my last step says to multiply, I need to, if I'm going to multiply fraction times, or I'm going to multiply by a fraction, I need to turn 14 into a fraction. So you're either going to turn your number into a fraction, or you're going to turn your number into a fraction by putting it over 1, or if it were a mixed number, you would want to change it into an improper fraction. So we're going to multiply. We've got 14 over 1 times 9 over 7. Looking across from each other, 14 and 7 have 7 in common. So that's a 2. That's a 1. 9 and 1. Only common factor is 1. So now we can multiply. So 2 times 9 in the numerator is 18. 1 times 1 in the denominator is 1. And 18 over the 1 is the same as 18. So 14 divided by 7/9 ended up being 18. So the idea is change to division and then use your skills with fractions that you all have shown mastery of earlier this year. So here's a you do. What you do is you're going to pause the video at this point, try the question on your own, and then press play to look for the answer. If you get stuck, press play and listen to as much of the video as you need, and then try the problem on your own. So if we're going to do this problem, we're going to rewrite it as division. And then I'm going to change this into multiplication. Before I change this into multiplication, I'm going to rewrite 1 and 5/6 because to do this problem, so I'm going to multiply, then I'm going to add. 1 and 5/6 is really 11/6. So this problem is 11/6 divided by 3/4. I want to work with, if you remember, we want to work with improper fractions, not mixed numbers when we're doing these types of problems. I'm going to rewrite it as multiplication, keep, change, flip, and now I'm ready to multiply. 4 and 6 have 2 in common. And now I am ready to multiply. No more common factors, so 11 and 2 gives me 22. 3 and 3 gives me 9. I can leave my answer as 9 or 22 over 9, or 9 goes into 22 twice with 4 left over. So either one of those answers would be just fine. For the second problem here, rewrite as division. Keep, change, and flip. Oh, I wrote the wrong number. And flip. That's 8 over 3. 3 over 8 becomes 8 over 3. 8 and 15 don't have any common factors. 8 and 3 don't have any common factors. So all we can do is multiply. 8 and 8 is 64. 15 times 3 is 45. And you could leave your answer as 64 over 45, or 45 goes into 64 once with 19 left over. So either one of those answers would be okay. So for our complex fractions, it's division of fractions. It just looks a little more complicated. We're going to do a couple of unit rate problems here, and these are going to look very similar to what when we talk about dealing with unit rate and dealing with complex fractions. The only difference between this problem and a problem that we've done the past few days is that now our numbers that we are doing for our rates are fractional. So we're going to do the exact same thing. We're looking for, so it says that Josiah can jog 1 1/3 miles in 1/4 of an hour. Not all of our numbers are always going to be nice and even. Somebody doesn't necessarily go 3 miles in exactly 2 hours. So we're going to be looking for the same source of information, but fractional numbers. So we're looking for our rate as miles per hour. That means for our rate, the miles are going to go on top and the hours are going to go on bottom. So if we want to do our unit rate, we'd think blank per blank to get our what goes in the numerator and what goes in the denominator. And now we're going to fill in the numbers. So I have 1 and 1/3 miles in 1/4 an hour. I want the average speed, aka I want his miles per hour, his unit rate. So I need to divide. So I need to do 1 and 1/3 divided by 1/4, which that is 4/3 divided by 1/4. So I'm going to keep, I'm going to change, and I'm going to flip, and that is 16 over 3, which means for this one, it's better to change it into the mixer, because if I'm going to tell you miles per hour and I say, hey, that person was going 16 and 16/3 miles per hour, that kind of doesn't have a whole lot of meaning to us. But if I say that 3 goes into 16/5, and I have 1 left over. If I told you somebody was going 5 1/3 miles per hour, that's going to have a little bit more meaning to you as far as getting an idea of how fast they are going. So our unit rates are going to be the same process, it's just different types of numbers. So you have 2 problems left here that you're going to try. They are up on the screen now, and you are going to try and pause and work. Actually, you're not going to pause, you're going to end the video and work on these problems. When you are finished, you are going to check these problems in with myself, so that we can check and make sure of where your understanding is right now. So go ahead and stop the video and try these problems on your own.